Hello everyone, a very good morning all of you and a very warm welcome to you all to this wonderful numerical practice session for ISRO 2023 exam. So please do let me know if I'm audible and visible to all of you so that we can start this session. I have selected some beautiful questions from each and every corner of fluid mechanics, fluid kinematics, so that you will be able to revise your concept through these questions. All right. So please keep your pen and notebook and try to solve as many questions as possible on your own and try to recollect your fundamentals. And in case of any difficulty, you can always connect with me through the comment section. So please do let me know if my audio and visual quality are fine so that we can start as soon as possible. Can you hear me? Those who are watching me live, please mark your presence and do not forget to share this session link to all your friends and colleagues so that others can also join the session and get benefited. All right. आवाज आ रही है मेरी आप लोगों को? So kinematics, I am having around 15 questions in total. The session will be around 45 minutes and we will try to relate or we will try to discuss the related concept through the question only. Okay, for those who are attending my session for the very first time, this is my quick introduction. I am having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared engineering services examination, BTech from IIT Delhi, worked in Steel Authority of India Limited for a couple of years, and I am quite comfortable in these many subjects. Hi Gaurav, welcome. How are you? So let me tell you about the fluid kinematics. Fluid kinematics is one of the important or one of the most important topic of fluid mechanics. And moreover, the questions framed are normally simple, straightforward, so that you can easily score the best possible marks in the kinematics. They cannot twist the questions from the kinematics much. Either they will be formula based, direct, put the values in the formula, get the answer. Or if they are a theoretical question, then they will be coming from the standard results. There are some standard results we discuss in the kinematics. So the theoretical questions are based on the standard results and the numerical questions are based on the direct formula. All right. So that makes the topic very important because so many students, those who revise the subtopic for quite enough time, are able to get the answer, are able to get the best score in the kinematics. All right. Hi Papa ka Gora, good afternoon, welcome. Am I audible and visible to all of you? आवाज आ रही है मेरी? So those who want to connect with me, you can use my mail ID chandra.shekhar7@byju's.com, or you can join me on the Telegram, that is Mechanical by Chandrasekhar. The link is mentioned on the bottom of the screen. Shall we start? किसी ने ये नहीं बताया कि मेरी आवाज आ रही है कि नहीं आ रही है? Am I audible and visible? अभी होगा. ऐप में मेरी 6 बजे क्लास है फॉर गेट एंड ESE. My app free class is at 6 PM today. 2-3 दिन से मैं लीव पे था. That is why the class could not happen. So today at 6 PM on app. All right. Model analysis we are going to discuss. Model analysis we will be going to discuss. ठीक है. Chaliye, let us continue our discussion. Please keep your pen and notebook and try to solve as many questions as possible. And even if you commit the mistake, please do take it positively and try to improve your weak areas. Try to promise yourself that you should not repeat those mistakes again in your actual examination. The first question is on your screen. I'm not able to. Yes. The first question on your screen, what is the answer to this one? Everyone, please give it a try. Question number 1. What is the answer to this one? A one-dimensional flow is the one which the flow can be classified as one-dimensional, two-dimensional, and three-dimensional. So for the flow to be one-dimensional, the flow must depend only on one space coordinate, or the velocity must be represented only by a single space coordinate. It can be time coordinate or not, that depends whether the flow is steady or unsteady. For an example, if we talk about one-dimensional unsteady flow, if the flow is one-dimensional unsteady, velocity will be a function of x and t only. T is for time unsteadiness. And if we talk about three-dimensional plus unsteady flow, for three-dimensional unsteady flow, velocity is a function of x, y, z and t. So if the flow is one-dimensional, it means velocity depends only on one space coordinate, or the flow can be described by only a single space coordinate. It can be x-axis, x coordinate, it can be y coordinate, it can be z coordinate, or it can be radial coordinate, tangential coordinate, anything. But there will be only one single space coordinate for the flow to be one-dimensional. And if the flow is one-dimensional, it means the fluid particles or the streamlines are straight. This is one-dimensional. This is one-dimensional. If the streamlines are straight, then the flow is one-dimensional. What is the correct answer? No, B is not correct. B is not correct. It is option C which is correct. The flow takes place along the streamline. If the flow is taking place in a curved path, then it is 2D flow. If the fluid is flowing in a curved path, then it is two-dimensional. But if the fluid is flowing in a straight line path, then it is one-dimensional. I hope it is clear. Question number option C is the right answer. The next one. Try to solve the next two question. Everyone, please give it a try quickly. The liquid is flowing separately. The liquid is flowing separately through each of the two pipes whose diameters are in the ratio of 2:1. So the ratio of D1 by D2 is 2:1. The ratio of diameters is 2:1. If the ratio of the velocity of the flow in the two pipes, V1 by V2, is equal to 1 by 2, then the ratio of the amount or the liquid flowing per second, what is called as liquid flowing per second? That is the discharge. So what will be the ratio of discharge Q1 by Q2 between these pipes? What is the answer? Question number 2, what should be the answer? The ratio of Q1 by Q2. As Q is equal to constant for continuity equation, according to continuity equation for steady and incompressible flow. If it is not mentioned, sometimes about the flow no information is given. Sometimes for the flow information, the complete information is not given. We will always assume the flow to be steady, incompressible and two-dimensional as long as there is no information available for the type of the flow. Are you getting the point? Because in general we are going to analyze two two-dimensional steady and incompressible flow. So continuity equation for steady and incompressible flow, that is Q is equal to constant, it is one dimensional because the question is about the discharge and velocity and diameter. So Q is equal to, can we say Q is proportional to d square into V? So Q1 by Q2 is equal to d1 by d2 whole square into V1 by V2. Put the value, what is d1 by d2? 2 is to 1. So it will be 2 square into 1 by 2. The answer will be 2 is to 1. Yes, well done Gaurav. Papa ka goda, good. Option A will be the correct answer for this one. It is relation based question. If you are able to develop the right relationship, then you will be able to get the correct answer. Let us move to the next one. Question number 3 on the screen. Question number 3. Give it a try, every one of you. There are two small orifices. Orifice means the hole. There are two small holes, A and B of diameters 1. This is dA and diameter of B is 2 cm respectively. The size of the orifices are different, which are placed on the side of a tank at a depth of H1 and H2 below the open liquid surface. The depth of orifice A is H1 and the depth of orifice B is, are you talking about question number 3rd? Are you giving the answer for question number 3 or question number, what is the answer for question number 3? If the discharge through A and B are equal, it means QA is equal to QB. Then what is the ratio of H1 and H2? We need to find a relation between H and diameter, isn't it? The objective is to find a relation between H and diameter. So if this is a tank and if there is an orifice here, this is the free surface and orifice is, let us say, at a depth H. What will be the velocity from the orifice? It will have a projectile motion like this. So the velocity here will be given by under root 2gh. Depth is called as torsal equation. The velocity will be given by root 2gh. Torsal equation. So V is proportional to, from here we can say, that is called as torsal equation, or that is obtained by applying the Bernoulli principle. This expression is obtained by applying the Bernoulli principle. So V is directly proportional to root h, that is equation number 1, or we can say H is proportional to V square. H is proportional to V square and the discharge is also constant. Q is proportional to D square into V is constant. Discharge is constant. So we can say V is inversely proportional to D square and V square is inversely proportional to D to the power 4, isn't it? If we put it the value here, if you put the value, discharge is constant, so V is inversely proportional to D square, or V square is inversely proportional to 1 upon D to the power 4, isn't it? So if we connect these two expressions, H is directly proportional to V square and V square is inversely proportional to D to the power 4. From here we can say H is inversely proportional to D to the power 4. The question is to find out the ratio of H1 by H2. So it will be dB by dA to the power 4. What is dB? 2 by 1. So 2 to the power 4, that is 16:1 is the answer. What is the answer? 16:1. Option A, question number 3, option A is the correct answer. Isn't it? Any doubt? If anybody is facing any doubt, you can just let me know. Otherwise, the next question is theoretical. The next one. Consider the following statements. Statement number 1, it is kind of MSQ. The statement 1 says there is no flow across a streamline. Is the statement true? So which of the following statements is in respect to the stream flow pattern are correct? We need to find out the correct statement. Yes, the flow is always along the streamline. The velocity must always be tangent to the streamline. There is no flow across the streamline. The flow always, the normal velocity will be 0, tangential velocity will be non-zero. So the flow is always tangent to the streamline. So that is correct. Streamline spacing varies directly with velocity at a section. So whenever the velocity increases, why the velocity is increasing? Because area is decreasing, and if area is decreasing, it means the spacing between the streamline decreases. When area will decrease, then the velocity will increase. That is nozzle. In case of a nozzle, if it would have been a diffuser, area increases, velocity decreases. So the streamline spacing varies inversely, not directly, inversely with the velocity at the section. So 2 is not correct. Statement 2 is incorrect. What about third? Streamline do not cross. Yes, because the tangent at any point represents the velocity, and if streamline cross at the intersection point, there will be two tangents. There will be 2 tangents. So streamline cannot cross. Path line can intersect, but streamline cannot intersect, because at the intersection point there can be 2 tangents drawn, and 2 tangents can be drawn. It means that direction of velocity have there will be 2 directions of velocity, which is impossible. So statement 3 is correct. In a steady flow, streamline pattern does not changes with time. Yes, when the flow is steady, the flow behavior does not change with time. So the equation of the streamline will be a function of x and y. The equation of the streamline will not be a function of time. That is also true. So 1, 3, 4 are the correct answer. Option C. Well done, guys. Gaurav, Papa ka ghoda. Good, good. Keep it up. So 1, 3, 4 are the right answers. Let me move to the question number 5. Let me see who will give me the correct answer for this one. Everybody. This is an open challenge. Who is going to give me the right answer for this one? Prandtl's pitot tube. It is a combination of Bernoulli principle and kinematics. Bataiye. Who will be able to give me the correct answer will get a chocolate. Do you know what is a Prandtl pitot tube? It is also known as pitot static tube. There are 2 types of velocity measuring instruments. One is simple pitot tube. If we talk about a simple pitot tube, it is an open-ended tube having 90-degree bend. This is a pitot tube. This is pitot tube. And what is pitot static tube? There is a pitot tube like this, and there is a static tube covering the pitot tube like this. There are 2 concentric tubes. This is known as pitot static tube. There are 2 openings here. This is the pitot static tube. So the outer tube will measure the static pressure, and the inner tube will be measuring the stagnation pressure. So the difference of this static and stagnation pressure will be the dynamic pressure. That is how it works. HMT के क्वेश्चन चाहिए लाइट बल्ब? जरूर HMT के भी क्वेश्चंस करवाएंगे. जब फ्लूइड मैकेनिक्स के करवाते हैं तो HMT चाहिए होता है तो स्टूडेंट्स को, और जब HMT करवाते हैं तो फ्लूइड मैकेनिक्स चाहिए होता है. तो जो भी करवा रहे हैं आपके इनपुट की मदद से ही हमने प्लान किया है. आप मेरे को इनपुट देते रहिए, एंड आई विल ट्राई टू ब्रिंग द ऑल टाइप ऑफ सेशंस व्हिच आर गोइंग टू यूजफुल फॉर योर एग्जामिनेशन. इस क्वेश्चन का आंसर बताइए. यस, कितना श्योर हो? गौतम, पापा का घोड़ा, सबने सी बोला है क्या? मुझे नहीं पता. आप पिछले क्वेश्चन की बात कर रही हैं, इस क्वेश्चन की बात कर रहे हैं. क्वेश्चन नंबर 5, डिड यू से सी? देखिए हाउ इट वर्क्स, ट्राई टू अंडरस्टैंड द इनर ट्यूब. एवरीबडी लिसन वेरी केयरफुली. 5 का ए, गौरव 5 का ए बोल रहे, सब लोग ध्यान दीजिए. दिस इज हाउ द पिटोट-स्टैटिक ट्यूब इज. Normal pitot tube is a single open-ended tube having a short 90-degree bend. It is something like piezometer, but the extra thing is there is a bend, and it is always kept parallel to the flow or aligned to the flow. So whenever it is kept aligned to the flow, it measures the stagnation pressure. So pitot tube always measures the stagnation pressure, which is combination or which is sum of static and dynamic pressure, right? Now, if there is an outer covering, there is another tube which is covering this pitot tube, then we call it as pitot-static tube, or we can start calling it as Prandtl's pitot tube, because Prandtl had developed this tube. So why it is used? Because pitot tube only measures the stagnation pressure. So we need to measure the static pressure again using some other instrument like a piezometer, gauge, pressure gauge, etc. Because we require the stagnation pressure, we require the static pressure, and then we will subtract these two and we will obtain the dynamic pressure, and dynamic pressure gives us the velocity. That is how this instrument works. So Prandtl had developed a single instrument which is having the concentric tubes or concentric tubes, open-ended concentric tubes. The outer tube measures the static pressure. It is like a piezometer, but the inner tube measures the stagnation pressure. So the opening of the inner tube is kept parallel to the flow, but opening to the outer tube is kept perpendicular to the flow. Whenever the opening is perpendicular to the flow, it measures the static pressure. Whenever the opening is parallel to the flow or aligned with the flow, it measures the stagnation pressure, because the velocity here will become 0, right? Now, the tip reading varied only across the flow. This is the tip. At tip, velocity is equal to 0, stagnation point. At the tip, there will be stagnation point. So the tip reading varies only across the flow. It means, what does that mean? So tip measures stagnation pressure. Tip measures stagnation pressure. Stagnation. What is stagnation pressure? Static plus dynamic. What is stagnation pressure? Static plus dynamic. Static plus dynamic. So it means, because across the streamline pressure remains constant, static pressure remains constant. There is no variation in the static pressure across the streamline. Only when the streamlines are curved, then only the pressure varies across the streamline. Otherwise, for the straight streamline, pressure remains constant. It does not change. Are you getting it? So it is only the velocity which is changing. So we can say across the streamline there is a change in velocity. Here velocity is v1, here velocity is v2, here velocity is v3, something like this, v4 and v5. So if at a particular section, if the velocity varies across the streamline, do you agree that is non-uniform? Sorry, do you agree it is rotational flow? There is a relative motion. Do you agree it is rotational flow? Because there is a relative motion, and whenever there is a relative motion, shear stress is developed. Shear stress will develop the shear force, and shear force will produce the torque. There is a rotation. So rotational flow. This line specifies us, this statement specifies that the flow is rotational. Do you get it? Are you getting it? If the velocity is varying at a particular section, if the velocities are different across the streamline, if the velocity is variable, like the parabolic variation, logarithmic variation, in turbulent flow the variation is logarithmic, in laminar flow the variation is parabolic. So they are all real and rotational flows. So it is the real flow. That is why it is called as real flow, and we can call it as rotational flow. While the side opening, this is the side opening which measures the static pressure, and static pressure reading varies only in the direction of the flow. It means the pressure varies in the direction of the flow. Pressure varies And if the pressure varies in the direction of the flow, do you agree velocity also varies? The velocity will vary in the direction of the flow. If the pressure varies in the direction of flow, velocity will also vary in the direction of the flow. When the velocity is varying in the direction of flow, do you agree it is non-uniform flow? Do you get it? The flow will be non-uniform. I hope this is clear. So the correct answer is non-uniform and rotational. How many of you had given me the right answer? Nobody? D will be the correct answer, and please do let me know honestly if you have understood the concept or not. That is more important. Even if you are not able to give me the answer correctly, you can improve yourself. But if you do not ask me your doubts, then that will not get cleared. Is the concept, is the understanding clear for this one? Can we proceed further? Good. The next question, question number 6 on your screen. Question number 6. Give it a try. It is very simple. X component of velocity in a two-dimensional incompressible flow is given by u, and what is the y component of velocity is 0 at y is equal to 0. Then the expression for y component of the velocity is given by, it is two-dimensional flow. So v is a function of x and y. V will be a function of x and y. We need to find out this. So for two-dimensional and incompressible flow, for two-dimensional incompressible flow, if we write the continuity equation, according to continuity equation, del u by del x plus del v by del y is equal to 0. What is del u by del x? From here you can find out del u by del x. Del u by del x is equal to, first term will be 0 and 6y. So 6y plus del v by del y is equal to 0, or we can say del v by del y is equal to minus 6y. It is partial derivative. If we integrate with respect to y, if we integrate this with respect to y, so we can say v is equal to minus 6 y square by 2 plus the constant can be a function of x. The constant can be a function of x. So to find out the value of fx, so v is equal to minus 3y square plus fx. To find the value of fx, the condition is given, the y component velocity is 0 at y is equal to 0. At y is equal to 0, the velocity will be 0. So we can say from here fx will be equal to 0. So v is equal to minus 3y square, isn't it? What is the need of this y component of velocity? It should be like this, plus constant. It can be a function of x, it can be. So it should be minus 3y square, or you could have said minus 3y square plus fx. D will be the answer. D will be the correct answer for this one. Isn't it? D will be the answer. Shall we proceed further? Good. So we have recently started a crash course. If you guys are aware that the crash course is going to be very, very beneficial. Why? Because in a short duration, we are going to cover the entire syllabus. If you are preparing for GATE 2024 and if you have not covered your syllabus yet, then this crash course is going to be very, very helpful, because we will be giving you the numerical practice sessions also. We will discuss the numericals. We will provide you the mock test as well as the question bank, and the theoretical classes or the conceptual classes will also be going to happen in a concise manner, covering the entire syllabus. So do enroll yourself if you want to be part of our paid course, if you want to have our guidance to crack this GATE 2024 examination with the best possible score. You can call the mentioned number for more clarity, for more about our paid course. Let us move to the next one, question number 7. Question number 7 on your screen. Consider the following statements. Consider the following statements. Which of these statements are correct related to fluid kinematics? Now, can you solve this question? Can you let me know the answer? Yes, everyone, read each and every statement and try to judge whether a particular statement is correct or not. I told you theoretical question can be asked from the direct results. The first statement says a streamline is an imaginary line within the flow. That is true, for which normal at any point relates to the acceleration at that point. Is statement 1 clear? It is, the streamline is defined such that the tangent will be the velocity and the component of velocity in normal direction will be 0. That is how the streamline is defined. It does not guarantee anything about the acceleration. If the streamlines are curved, then there is a normal acceleration which is in normal direction to the streamline. But that is only developed when the streamlines are curved. For a straight streamline, there is no normal acceleration. So we cannot say that the normal always represents the acceleration of the flow. The convective acceleration, there are two types of acceleration, convective, that is also called as advective. The convective acceleration is the change in velocity with respect to distance only. When the velocity is a function of space, or if it is non-uniform flow, then convective acceleration will be non-zero. For non-uniform flow, that is convective acceleration will be developed. The temporal acceleration, or we can also call it as local acceleration, expresses variation of velocity with respect to time. If velocity is a function of time, it is called as unsteady flow. And for unsteady flow, local acceleration will not be 0. So that is C. Third is also true. And what about fourth? Both convective acceleration and temporal acceleration can coexist. Yes, if the flow is non-uniform and unsteady, both can exist. It does not mean if the convective acceleration is 0, then normal acceleration has to be 0. So 2, 3, 4 are the correct answer. D is the right answer. D will be the answer. Yes, Lakshmi Narayan, well done. Papa ka ghoda. Gaurav, it is not C, it is D. Convective and temporal both can coexist, or any one can exist. Any one of them can exist. If the flow is steady and non-uniform, then local will be 0 but convective will be non-zero. If the flow is unsteady and uniform, then local will be non-zero and convective will be 0. If the flow is steady and uniform, then local and convective both will be 0. But if the flow is unsteady and non-uniform, then local and convective both will be non-zero. Clear? Let us move to question number 8 now. The next question, question number 8. The stream function is given by 3x square minus y square. What should be the magnitude of velocity at point 2, 2? Lakshmi Narayan, local, steady, local will be 0, unsteady, local will be non-zero, uniform, convective will be, for uniform flow, convective will be 0, and if it is non-uniform, convective will be non-zero. So if the flow is unsteady and uniform, then local acceleration will only exist. If the flow is unsteady and uniform. Do you get it, Lakshmi Narayan? Is this clear? For unsteady and uniform flow, the local will be non-zero and convective will be 0, right? Yes. The next one. The next question is this. The stream function is given by this expression. What is the velocity? Magnitude of velocity at point 2, 2. What is the answer? So, if the stream function is given, the velocity in x direction is given by del psi by del y. What is del psi by del y? It will be minus 2y. And at 2, 2, at point 2, 2, u is equal to minus 4 meter per second, isn't it? And v is given by minus of del psi by del x. V will be given by minus of del psi by del x. So what is minus del psi by del x? Minus 6x. So what is V at 2, 2? Minus 12 meter per second. So what is the magnitude of velocity? Under root of u square plus v square. That is the magnitude of velocity. So put the value, you will get the answer. अच्छा आंसर मैच नहीं हो रहा. आंसर मैच नहीं हो रहा. क्या आंसर आ रहा है? What is the answer? 12 into 12, 144 plus 8, 1. Plus 16, 144. So root of 160. Are you getting 13? It will be 12.6 something. Yes, so it is close to 30. Yes, it is close to 13. Square of 13 is 169, right? So B should be the answer. It should be B, the nearest option. Whatever will be the nearest option will be treated correct. 12.64. Are you getting 12.64? For the given stream function. Hi Aman, good afternoon. Acha. Thank you very much. So the answer will be 13. 13 will be correct answer. Can you find out the velocity potential function for the given stream function? If psi is given by, can you find out the corresponding stream function? Can you find out the corresponding velocity potential function? Yes. If psi is equal to 3x square minus y square, can you find out the velocity potential function phi? Phi as a function of x and y. So what we will do? We will differentiate this. If we differentiate this, then we can say d phi is equal to del phi by del x into dx plus del phi by del y into dy. And here, from here we can say del phi by del x is equal to minus of del psi by del y, and del phi by del y is equal to del psi by del x. So what is minus of del psi by del y? 2y. And what is del psi by del x? That is 6x. So put these values. Put these values here. So d phi will be equal to del phi by del x is 2y into dx plus 6x into dy. So if we integrate these, if you integrate, then phi is given by 2y into x plus 6x into y. So it will be 8xy. Phi will be given by 8xy. This is the velocity potential function. This will be the velocity potential function for the given stream function, isn't it? 8xy. Well done. Good. So let us move to the next one then. The next question, question number 9. Sorry, it is not question number 9. It is question number 10. Question number 10, give it a try. Question number 10, everybody please do solve it. In a parallel two-dimensional flow, there is a parallel two-dimensional flow like this. In the positive x direction, the velocity varies linearly from 0 at y is equal to 0 to 75 meter per second at y is equal to 1. The variation of velocity is linear. So u is a linear function of y. If it is a linear function of y, we can write u is equal to ay plus b. That is our assumption. Can you solve this one? What will be the expression for psi? What will be the expression for psi? Beautiful question. If u is a function of y, we can say psi will be a function of y only. It is one-dimensional flow. So at y is equal to 0, u is equal to 0. That is first condition. So b will be equal to 0. At y is equal to 1, u is equal to 75. So a is equal to 75. So our expression will be u is equal to 75y. This is our expression. And here we can say psi will be a function of y only. Stream function will be also be a function of y only. So d psi by dy is equal to u. D psi by dy is equal to u. That is equal to 75y. So psi is equal to 75y into dy. So psi will be equal to 75 y square by 2. $37.5 y square will be the answer. C will be the correct answer. 37.5 y square. Answer to question number 10. Clear? Let us move to the next one. Question number 11. Very, very beautiful question. Question number 11. Please, everybody give it a try and let me know the answer. At a point on a streamline, at some point on a streamline, the velocity is 3 meter per second. So if there is a streamline, let us say, so the velocity is 3 meter per second. Velocity is always tangent to the streamline. So it is the tangential velocity, that is 3 meter per second. We can call it as tangential velocity. And the normal velocity will be 0. If it is curved streamline, then the normal velocity will be 0, but the tangential velocity will be non-zero. And the radius of curvature r, it is a curved streamline, so the radius of curvature is given by 9 meter. If the rate of increase of velocity along the streamline at this point is given by this 1/3 meter per second per meter, so it is dv by dx, 1/3 meter per second per second. So it is dv by ds. It is dv by ds. Rate of variation of velocity with the space is given, and then the total acceleration at that point would be. So the total acceleration will have two components, tangential as well as normal. Tangential is non-zero, normal is non-zero. There will be two acceleration. So if we write the tangential component of acceleration, that is the local plus convective. This is tangential acceleration, local plus convective. So what is del v by del t? Because this is velocity is not changing with time, that will be 0. What is vt? Tangential velocity is 3 into dv by ds is equal to 1/3. So 1 meter per second square is the tangential acceleration. And what is the normal acceleration? Normal acceleration is given by local plus convective, vt square by r. So this will be 0 because Vn is 0. So Vt square, that is 3 square upon r. So 9/9, that is also 1 meter per second square. If the question asks you about the normal acceleration, your answer will be 1. If the question asks you about the tangential acceleration, your answer will be 1. And as the tangential acceleration is perpendicular to the normal acceleration, magnitude of the total acceleration is at square plus an square under root. So it is 1 square plus 1 square under root. What is the magnitude of total acceleration? That is root 2 will be the answer. Answer will be root 2. The magnitude of total acceleration will be root 2. D will be the correct answer. It will be under root of 2. It will be root 2. Do you understand it? Root 2 will be the answer. I hope it is clear to everyone. So this is called as natural coordinate system. This coordinate system is known as natural coordinate system. Which is developed for curved streamlines. When the streamlines are curved, so we use natural coordinate system. So please guys, do like and share this session to all your friends, those who have joined me late. And tomorrow we will be having a discussion on fluid dynamics. We will be having this free practice session on YouTube for ISRO 2023 for fluid dynamics. Please do revise before coming to the next class. And Today at 6 p.m. I will be coming live again, but on on BYJU'S app. At 6 p.m. there will be a free practice session for GATE and ESE 2024 on BYJU'S app, and the topic will be model analysis. So do not forget to join me today at 6 also on the app. गौरव क्या एक्सप्लेन करूं? देखिए, look, for curved streamlines, the concept is for curved streamline. If there is a curved streamline like this, if the streamline is curved, so at any point, if we draw a tangent, at any point, if we draw a tangent, then there is a tangential velocity which is non-zero. If we draw a normal at any point, this is normal, this is tangent. If we draw a normal, so Vn is equal to 0. But for curved streamline, the acceleration, the tangential acceleration is also non-zero, and there will be a normal acceleration which will be non-zero. This is called as centripetal acceleration. We can call it a centripetal acceleration. This is developed when the streamlines are curved. For curved streamline, centripetal acceleration is developed. So there is a tangential acceleration, there is a normal acceleration. For curved streamline, there are two type of acceleration. नहीं मेंस के क्वेश्चन नहीं होंगे, मेंस के क्वेश्चन नहीं होंगे, प्रीलियम्स वाले क्वेश्चन होंगे, मेंस के अभी नहीं, 2024 के प्रीलियम्स के लिए. सो अगर टेंजेंशियल एक्सेलरेशन चाहिए तो हम बोलेंगे लोकल डेल वी बाई डेल टी प्लस वी टी इंटू डेल वी टी बाई डेल एस. दिस इज लोकल, दिस इज कन्वेक्टिव. सिमिलरली नॉर्मल एक्सेलरेशन लिखें del Vn by del t, that is local, plus Vt square by r. If you remember, V square by r is called as centripetal. V square by r, that is called as centripetal acceleration. ये क्वेश्चंस होंगे क्वेश्चंस. तो ये वैल्यू जीरो हो जाएगी, del Vn by del t will be zero because velocity, normal velocity is always zero. So this is called as centripetal acceleration. And if we want the total acceleration, then it is algebraic addition of tangential and normal. Because tangential and normal are perpendicular to each other, this is called as natural coordinate system. We call it as, this is local, this is convective. The system is called as natural coordinate system. Do you understand it? Okay, fine. I will share the PDF of this session to my Telegram channel also. If you have not joined me on the Telegram yet, please do join. It will help you to improve your preparation and to motivate you for the better future. So do not forget to join me on the Telegram. I have already shared the link in the starting of this session. The next question is related to the rotation of the fluid. The component of rotation for a three-dimensional flow. So if we compare this, it V is equal to Ui cap plus Vj cap plus Wk cap. So we can say U is equal to y square plus z square, V is equal to x square plus y square, and W is equal to, is also x square plus y square. So at 1, 2, 3, we need to find out the angular velocity. What is the answer? So omega x is equal to half into del v by, if we talk about omega x, then it will be del y minus it will be del z, it will be del w del V. So half into what is del W by del Y? Del W by del Y, 2y. It is 2y minus del V by del Z, 0. So it will be y. And y is equal to 2. So it will be 2 radian per second. It will be 2 radian per second. So option D is the correct answer, isn't it? Are you getting 2 radian per second or not? Omega x, half into the options might not match. Omega x. Similarly, if we want omega y, half of, then it will be z minus x u w. So half of what is del u by del z? That is 2z. Del w by del x, it will be 2x. So it will be z minus x. What is z minus x? Z is equal to 3, x is equal to 1. So it will be 3 minus 1. 2 radian per second. Options are not matching here. 2 radian per second. And if we talk about omega z, half of, it will be x, y, del v by del x minus del u by del y. So half of, what is del v by del x? Del v by del x, 2x. Del u by del y, 2y. So it will be x minus y. X is 1, y is equal to 2, so it is minus 1. So omega x is 2, omega y is 2, omega z is minus 1 radian per second. D will be the correct answer. There is a slight mismatch, isn't it? D looks correct. So it will also be 2. Omega x, omega y, omega z will be, if we remove this minus 2. Omega x will be 2, omega y will be 2, omega z is equal to minus 1. Are you getting it? And this Sunday, there will be an scholarship test, national level scholarship test. You can register yourself. The registration is completely free. And based on your performance in the scholarship test, you will be able to avail the discounts or the scholarship in our various courses. So do not forget to be part of the scholarship test on Sunday, 1st of October. The next question, question number 13. The next question, please do solve the next one. A velocity field is given by u is equal to 3xy and v is given by this 3 by 2 x square minus y square. What is the relevant equation of the streamline? What is the differential equation of the streamline? dy by dx is equal to v by u. So if you put the value, then v is equal to 3 by 2 x square minus y square. And what is u? U is equal to 3xy. So this 3 getting cancelled out. So dy by dx is equal to x square minus y square upon 2xy. X square minus y square upon 2xy. That is dy by dx. But the options are dx by dy. So from here we can say dx by dy. Dx by dy is equal to 2xy upon x square minus y square. D is the answer, isn't it? D will be the correct answer. dx by dy is equal to 2xy upon x square minus y square. This is your assignment question. नहीं, ये नहीं है. These two are your assignment question. This is assignment number 1. Please give it a try and share your answer with me. And this is your assignment number 2. Please do solve these two questions and share me the solution through my Telegram channel, or you can share your solution to the comment section here itself in this session, and you can also share your answer with me through my mail ID. So this is the mail ID to join, to connect with me, or you can join me on the Telegram, Mechanical by Chandrasekhar. I will provide the PDF of this session to my Telegram channel. All right. So that is all from my side, guys. I will see you today at 6 p.m. for the app free class, and tomorrow we will meet again on the YouTube for the fluid dynamics. So this is from my side. Let me take your leave. Have a good day. Enjoy. Take care and see you tomorrow. Jai Hind.